Hi guys. Today we're starting Unit 2, which is about quadratic equations. Um, so we're going to start just by kind of going over what makes a quadratic and just some of the key features of quadratic. Quadratic equations are polynomials where basically it's just it's going to have an x squared term, and that'll be the biggest exponent that there will be in the equation, and there won't be anything like square roots or logarithms, or the x won't be in the exponent or anything like that. So there's really two forms that we're gonna look at mostly. So there's standard form, where it's y equals, or f of x. Let's see what f of x is. Ax squared plus bx plus c, where a, b, and c are all real numbers, and a does not equal 0. B and c could equal 0, but a can't, for it to be quadratic anyway. So that's standard form. That's probably the most often or the most common form that you'll see. Next would be vertex form. So that is where you're going to have f of x equals a, and then in parentheses x minus h squared plus k, where hk is the vertex, which we'll talk about in a second. So notice again, you always have the x squared. The only time you don't actually see the squared is when you have factored form. So that is when you're going to have f of x equals a times x minus pick two letters. Let's do r and s and x minus s. So basically, if I multiplied those factors out, I would have a quadratic, but the factored form is where it's two factors. And one thing to keep in mind is that the a is the same for all of them. Like a is a, regardless of what, because you can transfer these into different, like all different forms. Like every quadratic can be written in each of these forms, but all of them, the a is always a. If that makes sense. It's important because we eventually see what a does to the equation. But anyway, so the shape of a quadratic is called a parabola. Not a parabola, but a parabola. And basically, it's a curve that looks either like a U, or it can look like a hill. It can be very skinny. It can be very wide, like that. But those are all parabolas. They can face up, face down. It's not very pretty drawing, but okay. So here's a much prettier picture of a parabola. And we have already talked about the intercepts before when we were talking about functions, but something more specific to quadratics would be the axis of symmetry and the vertex. So the axis of symmetry is a line that basically cuts the parabola into two equal halves. So it's essentially like it's in the very middle. It runs through the middle point and just cuts it smack dab in half. That's why it's called the axis of symmetry, because if you folded the parabola on the axis of symmetry, the two lines would like meet up, they would touch because they're symmetrical. The vertex is where the parabola touches the axis of symmetry. but AOS. You know what I mean? All right, and the vertex is always either a maximum, which is the highest point, which we have talked about, or a minimum. It's always one or the other because parabolas are always the same shape. So it's either at the very, very top or at the very, very bottom, depending on which way the arrows are going. Okay. So the vertex is always the maximum min, and it always touches the axis of symmetry. So for each of these, we are going to use the graphs to find the axis of symmetry and the vertex. So we are going to go over to something called GeoGebra. If you have a graphing calculator at home, awesome. If not, you have access to the internet and you can go there. It's on Nearpod. So geogebra.org/calculator. If you just Google GeoGebra, this pops up. And I need to go back and see what my equation was because I forgot. So it is, for crying out loud. Okay, negative 2x squared minus 4x plus 1. So I'm going to type in negative 2x squared minus 4x. I think it was plus 1. And it puts the f of x in there for me. Yes, I was right. Okay, so it gives me the graph of the parabola. As you can see, it goes on forever. It's this green graph right here. So the axis of symmetry is where it is going to be cut in half. So, anyway, so if you, I can't really show you because I can't really draw on this, but if you'll notice, right when x is -1, if I drew a vertical line there, that'd be right smack dab in the middle of that parabola. So an axis of symmetry is a line, and lines are written by equations. So the axis of symmetry is at x equals -1. The actual vertex is the point -1, 3. So I don't know why it's making me do this every time. I want to go back and forth. But the axis of symmetry was x equals -1, and the vertex was -1, 3. Now the x of the vertex and the axis of symmetry will always match because it's where they touch, okay? So let's look at the other one. 1/2 x plus 4 squared minus 2. Okay, 1/2, and then parentheses, x plus 4, close parentheses squared, minus 2. Right. Right. Okay, so notice how I can't really see it. So what I'm going to do is I'm going to zoom. Oops. What happened to my? Sorry. For some reason that disappeared. X minus 4. Oh, x plus 4 minus 2. Oops. Man, this is a horrible video. I'm doing a horrible job. X plus 4. Okay. No, not it. Why are you being weird? Okay. Just delete that. 1. Oh, that's why. There we go. Wow, that was silly. Okay. So it's the orange one. That was way more complicated than it should have been. Sorry. You all, well, we'll have like a keyboard, so it shouldn't be too bad. But anyway, it's the orange one, and if you'll notice where x is 4, that's where it cuts in half, and it's at the point -4, -2. So right now we're just looking at the graphs to find the vertex and the axis of symmetry. So the axis of symmetry is at -4, and the vertex is the point -4, -2. Okay. So last one is vertex form. X plus 4 and x minus 6. X plus 4, x minus 6. All right, so this is this bigger parabola. So once again, if I look at the, and if you can always, like on GeoGebra, if you need to see, can you all see what I'm doing? If you click on the one you're looking at, if you click on the point you want, it will tell you what it is. It'll tell you intersection points, it'll tell you intercepts, and it'll tell you extremum are either maximum or min. It's an think of it like an extreme point. Anyway, so the vertex is the point 1, -25, and even though you all might not be able to see the line, because the vertex at 1, -25, I know the axis of symmetry is x equals 1. Okay. It's very silly that it's making me do this every time. Okay. And I lost the other one. How rude. 1, -25. This was x equals -4 and -4, -2. Okay. So this half the week, we're just looking at key parts of a quadratic, getting used to using GeoGebra to look at graphs. On your homework, you are going to be asked to actually sketch the graph. So make sure you plot any points that you actually can see so that your graphs are as accurate as possible. And, oh wait, that's on the practice. The homework is different. You'll see. Sorry. Anyway, I will see you guys at the live meet, and I hope that you have a great rest of your day.